Hello and welcome back to Apt for You. In this particular video, we will be discussing a new problem from greedy algorithms, basically the activity selection. A very easy problem, easy to understand, but at the same time, very important, right? So let us just jump into the problem statement and understand what basically is the activity selection problem. So I have just taken a problem from Geek for Geeks and I'll be discussing the problem here and solving here itself, okay? So the activity selection problem says that we are provided with n activities with their start and finishing day. Means we are provided with some activities, some number of activities, and we are aware of the starting and the finishing time of that particular activity given in array start and end. So basically this particular array start holds the starting time of that particular activity, and this particular array end holds the ending time of that particular activity. So we are given with n activities, and every activity's starting and ending points are stored in these two arrays, okay? So we have to basically select the maximum number of activities that can be performed by a single person. Now assumption is very important, so we have to basically check the maximum number of activities that can be performed by a single person, assuming that a person can only work on a single activity at a given day. So at a given day means at any given day a person can work only on a single activity. This line is very important, right? Means at any given day a person can work only on a single activity, and likewise we have to finally decide how many maximum number of activities can be performed by the person. This will become more clear with the help of this particular example. Now supposing, let us take this better example 2. So what happens in example 2 is, you can clearly see we have 4 activities given to us. So this is activity 1, activity 2, activity 3, activity 4. To write more clearly, we can write activity 1, activity 2, activity 3, activity 4, right? And the starting point timing they are, means day 1, A2 will start at day 3, A3 will start at day 2, A4 will start at day 5, okay? The ending time is A1 will end at day 2, okay? And this particular job ending time is 4, then is 3, then is 6. So basically we have this data. This is the starting time and this is the ending time, right? So A1 has started its A1 job. This is an activity A1. This will be started on day 1 and will end at day 2. A2 will start at day 3, end at day 4. A3 will start at day 2, end at day 3. A4 will start at day 5 and end at day 6, right? Now we have to find the maximum activity that can be performed by the person, assuming that he performs only one job in a single day. In a single day he will perform only one activity, can work on a single activity, is clearly given here, at a given day, and duration of the activity, so this is important, he can work only on a single activity at a given day, and moreover how many maximum number of activities that can be performed by the single person. We have to find this, right? So duration of the activity includes both starting and ending day. Fine, this is given. So now let us see how we can do it. So if we see the approach to solve this particular activity selection problem, is the best optimal approach will be that you just try to sort this particular ending time, right? Means the time when which the activity will end, right? So the ending time of the activities will be sorted in ascending order, right? So here we can see they are not sorted in ascending order because you can see 2, 4, 3, 6, right? So 2 is small, it's fine, but we should have 3 next, but 3 is at this position, 4 is at this position, so this should not work. This activity, this particular thing should come before. But now if you write 3 here, then at the same time the position of this particular value in this array should also be changed. Getting the point? This should become 2 here, 3 here. This should interchange because these two are existing in pairs, isn't it? They are mapping to each other. That is, the activity 3 starting point is at index 2, the ending point is at index 2 here. So these two should be matching, right? So basically if I am shifting 3 here while sorting, then there should be a mechanism to ensure that I could easily track the starting point of that particular activity. Getting the point? So let us see what would happen. So basically now suppose I am trying to sort it. So basically I will be having 1, 2. So basically this is the starting time, this is the ending time, okay? 1, 2, and now this will become 2, 3. So this activity, this is 3 here, right? So this will come here, so 2 will also come here, then I'll go for 3, 4, and then I'll go for 5, 6. Fine. This is activity 1, activity 3, activity 2, activity 4. Now what will we do? The algorithm says that sort the ending time in the ascending order. Now pick the activity with the smallest ending time, okay, which means the activity that has finished very early. So right now we can see this particular activity A1, here has finished very early, right? You can see it is ending at time t2. So basically I'll pick this activity, and this activity will be performed first. Now when this job is done, when this job is completed, what was the ending time of this job? Ending time of this job was 2, which means that this job A1 started on day 1 and completed on day 2. So since this job completed on day 2, right, so I cannot take any other job that will exist on day 2. So you can see, come back here. Now compare the starting points of the other jobs. So this activity 3 here, starting point is 2, right? So starting point is 2. So basically I can pick this job here, but I would not pick. Why? Because they have said that in a single day a person can perform only a single job. So basically on day 2 he had also performed A1, right? Some part of A1 was also performed on day 2. So I'll assume that day 2 was already taken by job A1. So basically I'll not pick this job A3 here. Getting the point? I'll not pick this job A3 here. So what will I pick then? Come to next job. The starting point of A2 is 3, which is greater than the ending point of the last job. The last job ending point was 2, and the starting point of this job A2 is 3. Basically it is greater than, which means they are not overlapping. I can independently perform this after this job is completed. So I'll pick the job A2. Now this job ends at A4. Sorry, this job ends at time 4, day 4, right? So this job ends at day 4. So the recent completed job will be this. So the recent completed job pointer will point to this particular job now, right? Now move to the next job and compare its starting point with the recently completed job's ending time. Now this is 5 and this is 4, which means this particular job completed at day 4, and this particular job is starting at day 5. So basically there is no problem. I can complete this job also, right, after completing this job. So A4 will also be picked, and I will finish on day 6. Fine. So you can clearly see that we were able to complete 3 jobs: job A1, job A2, and job A4. So maximum 3 jobs can be completed given this condition. What is the condition? Again, I am repeating the condition because there is a slight variation in this particular question. They have strictly mentioned that the number of activities that can be performed by a single person, assuming that he can work only on a single activity at a given day. This is the reason why I did not consider this particular job. Right, because I know that job A1 already ended at day 2, so no problem. I should have picked this job A3 also, because it is starting at day 2. But in that case, what would happen? I would be doing 2 jobs in a single day. But they have already said that you can work only on a single activity at a given day, and the day 2 was already used for completing the job A1. So basically I'll skip this particular part. So basically my condition should be the starting time should be greater than the end time of last job. Fine. This should be my condition. The starting time should be greater than the end time of last job. You can clearly see the starting time is equal to the ending time of last job. So I ignored this. Come here. The starting time is 3 and it is greater than the ending time of the last job, 2. True. So I will pick that job, and the recent time of the last job will be equal to last job ending time, 4. This pointer will update here. Now again move to the next job, A4. The starting time of this job should be greater than the ending time of the recently picked job. So recently picked job was this particular job. Its time is 4. So this is greater than 4. True. So I picked up that also. So basically you can see that A1, A2 and A4. These were the jobs that will be completed, right? So maximum number of jobs that can be done is 3. So welcome back. Let us now try to implement the activity selection problem, right? So how to implement the code that we discussed. So I hope you are well aware of the algorithm that we discussed. The example that we will be discussing here will be, let us just write the example. So we will consider the example 2. Okay, so let me just copy it. Fine. So that's it. We don't need this anymore. Now come here. Fine. Great. So now we will try to implement whatever we discussed so far. So step by step we'll proceed with extremely detailed solution. Okay. So for that, what can we do is, first of all, let us write what we have received from the user. So we are provided with two things. What is the thing? We are provided with the value of n, which is nothing but equal to 4 in this case. We know the starting point. The starting points are 1, 3, 2 and 5, right? And the ending time of the activities are 2, 4, 3 and 6. As per the algorithm, we knew that first thing is to sort them. Sort in the basis of on the basis of ending time. But I also addressed an issue while discussing the particular algorithm, that at the same time while sorting we know that, suppose for in this case we know that 3 should come here, right? We are sorting in ascending order. Okay, so we know that when 3 comes here, at the same time in that specific array 2 should also come here, isn't it? Because 2 and 3 should always be mapping to each other, right? If 3 comes here but 2 remains still there, then what is the problem? The problem is, now you see the starting point will get deflected, right? But we need to ensure that the starting point and the ending point of every activity remains together. So that is A1 here, A2 here, activity 3 here, activity A4 here. How can we ensure that? So in order to solve that particular problem, a very important thing that we are going to do is here basically creating pairs. So we will create a vector, okay, pair of integer comma integer, right? We will create a vector pair of integer comma integer, and let us give the name job. Okay, so because each of them are a job, fine. Now we will declare a variable I equal to 0, suppose. Why? Now you see, for I equal to 0, I less than n. What is n? N is the number of jobs. It is passed in the function. You see, the value of n is passed in the function here, and this is the number of jobs. Or activities. So basically from 0 to n I will perform an iteration, and during the process I will try to create my vector array. So this array I will try to create, in which we will have elements in pair like this. We will have an element like 1, 2, 3, 4, 2, 3, 5, 6. You see the starting point and the ending time of every activity. Activity 1, activity 2, activity 3, activity 4. So in order to create this thing, what we are doing, we are going to use a vector pair array. Okay, the vector pair integer comma integer, the name is job. For 0 to n I'll just do the traversal, and I will basically say job dot pushback. Remember, we are basically pushing these elements there. Pushback. What do we push back? Start of I, right? Because you see, you remember the start vector that is passed as argument. This is basically storing the starting time, right, of the activity, comma the end of I. So what happens? Basically the start and the end time are pushed into this vector pair integer comma integer job, into this particular array job. So what we will get now? So finally we have a structure like this with us. We have this particular structure with us. Fine. Sorry. So we have this particular structure with us, and the name of this structure is nothing but job. What is the next step? Now we know that we need to sort it. So a very important step. Please pay attention. Now we need to sort it. So while sorting it, we have a command in stl sort. Now job is the vector array here. So job dot begin, we can write job dot begin, means from the starting position till job dot end. Fine. Sorry. Okay. Comma. So a very important thing I'll be discussing right now here. You see, this is the beginning of the job array. This is the ending of the job array. So from beginning to end, you have to sort them. Now you see, every array element exists in pair of integers, right? Every array element is existing in pair of integers. Now if I want to sort this array, what is the criteria on the basis of which we are sorting, right? There should be a criteria on the basis of which we are sorting. Now remember, the first parameter here, first value here is the starting time. The second value here is the ending time. So we are going to sort these elements in this particular array on the basis of their ending time. So for that I am creating a function here, comparison, compare, suppose comp. Okay, now this comp function should be declared as boolean. So I will declare it outside. So boolean function compare. Now what is it going to receive? It is going to receive, you see, this function will receive these two things, isn't it? This element and this element, right? It is going to receive two elements, right? Because we are going to sort the array elements of job. So basically it is going to receive these elements. And now what is this? Basically this is an element of type pair integer comma integer. So basically I should write here boolean compare pair integer comma integer, and let us suppose the name is j1, right, comma, I will receive one more array element, and that too will be of same type, pair integer comma integer, and the name will be j2, right? So basically I receive two array elements. Now the order in which we are going to sort is, we are going to compare their second element, the second element of every array element. So every array element has two numbers, so the second number, right, I'll compare the second number of this part and the second number of this array element, and then I will return the smallest one, right? So that is what I'm writing here, return j1 dot second, because we are comparing the end time, and the end time is basically the second value, right? The end time is basically the second value is end time, right? So basically I'm writing here j1 dot second less than j2 dot second. I hope you know what is j1 and j2. They are the array elements that we have passed, right? So j1 dot second will point to the ending time of the array element j1, and j2 dot second will point to the ending time of the array element j2. Now this will be returned. Remember, the type here should be basically static bool, okay? I will give the explanation to why am I using static here in the description. The reason why I am using static here, because if you don't write static, the compiler will give an error, right? There is some sort of error. It is an object oriented issue. So basically I'll give the description in the comment section, and you may refer the article that why we are using static here. So this is done. So what happens is, the array elements here, basically the array elements here will be sorted on the basis of this function compare, and this is basically helping me to sort the elements in the order of their ending time. So once they get sorted in the order of the ending time, what will happen? We have something like this. So we know that a1 a3 will come here, then a2 will come here, a4 will come here, right? a1's starting point is 1, ending time is 2. a3's starting point is 2, ending time is 3. a2's starting point is 3, ending time is 4, and a4's 5 and 6. So 5 and 6, right? Fine. Now what do we have to do? We are well aware of what we have to do right now. Now basically we should use a counter variable that will keep count of the number of activities I am actually able to perform, right? Count equal to 0. What next? Now at this particular time I will assume that, now you see, always in any case the first job here will always have the least time ending time. The first job will always have the least ending time, and in any case the first job will always be done, right? The first job will always be completed. So for that particular condition I'll be keeping a element of integer comma integer type. I'll declare element last, and this will point to this particular element, that is nothing but job of 0. So what will happen? Now remember, I used to say about the recently completed job. So this particular variable last will basically keep track of the recently completed job. Job of 0. This is the job array. Job of 0 is basically pointing to the, after sorting, the first element a1. So basically job of 0 is this is the variable last, is pointing to this. What should be our condition now? Now we are going to move from, for I is equal to 1, because 0 I have already taken, I less than n, I plus plus, and what next? Now I will come, remember what is the logic? Very simple. I hope you are smart enough. So basically we are going to compare the starting point of the jobs with the ending time of the last job. That is why I am going to write here, for I equal to 0, I less than I plus plus, if the starting point, now starting point is basically, we can say job of I dot first. Why? Because refer to the array element, and this is basically the second value, and this is basically the first value, right? The top. So basically this is the first value, this is the second value. So I want to compare the first value of every array element with the last value or the second value of the recently picked job. So last dot second, right? So this is nothing, very simple. This is my starting time, and this is my ending time of last job, right? So that is why I'm using this too. Now if I find the starting time to be greater, what should I do? Basically I should basically increment my counter by 1. So count plus equal to 1. Great. One more thing, we should now suppose, now what is happening here? So basically I am starting, this is the condition, last is pointing to this. Now the variable I is here. So the start of this is obviously not greater than this. So what will it do? It will loop. It will go further. The start of this is obviously greater than the last completed activity. So in this case, we will pick this job. So count increments by 1 again. So count was initially okay, fine. So one more thing, count should be equal to 1 here, because we are always taking the first job, right? The first job is always picked. So now count was initially 1, now count becomes 2 because this job is again picked. And at the same time, we should update this last pointer to point to this recently completed job, right? That is why we will write here count plus equal to 1 and last is equal to job of I. It should point to the job of I. Finally, what should happen next? Now again we will go further. The start of this is greater than the end of this. Okay, great. So what will be the counter? Counter becomes 3 and the job recently completed becomes here, comes here. Fine. So again we have already reached the end of the array. That's it. What should we return? This function should basically return the value, here, return count. Fine. And we can see the program will work fine. I hope it will work fine and will not have any issue. Okay, these silly mistakes always exist. Line number 30, let us see where is the semicolon. Alright, sorry for this. Great. So it has successfully compiled. Let us see if it is passing all the test cases. Great. So that's it for you, ladies and gentlemen. So thanks for watching the video. In case of any doubt, please feel free to put your doubts in the comment section. I hope this video was very helpful in understanding the entire process of implementing the activity selection problem. In case of any doubt, please put your doubt in the comment section and please like, share and subscribe. Thank you.